Hello and welcome to the Roto Grip Theory and Nomad Dagger Pro Shop webinar. My name is Victor Marion and I will be bringing you through this presentation. The theory tech data. Basically there's a couple things I wanted to point out about this bowling ball. As you can see, it has a 2000 grit Abralon finish on it, but it is introducing a brand new weight block, which would be the Triliptic core, and then it is also featuring a brand new Coverstock. So a little bit later in this webinar I will be going over that information and explaining what really sets this core and this Coverstock apart from some of the other balls that we've introduced. Now there is one interesting thing I would like to point out, that this ball, particularly the Triliptic weight block, is available in 12 through 16 pounds. So of course the densities are going to be different between a 12 pounder and a 16 pounder, but the actual shape itself is going to be the same. So it is something that adds a little bit extra for your customers that do indeed throw the 12 and 13 pound balls. Now here you can see the design intent. Whenever Roto Grip goes to introduce a brand new bowling ball, there needs to be a purpose or a reason behind it. So when it comes to the theory, we actually had a couple different things that we really wanted to get into and to introduce. Of course, we were looking for something that had a good mid-lane transition, very clean rolling. If we look back at, say, the Cell series, one of the things that made the Cell so incredibly popular was the fact that it was very continuous. From start to finish, it had a very clean rolling motion, very easy to read, great continuation through the pins. So wanting to follow up on that, we really wanted to try and introduce a brand new weight block that had those same key characteristics, but provided just a little bit more motion, a little bit more mid-lane. So with this, of course, we have the Triliptic core. As you can see on this three-dimensional CAD on the right, it really is, essentially it's three ellipses that have been stacked on each other. You've got the top and the bottom. Those balance out the central ellipses, and you'll notice how they're turned against each other. What this does is when the ball's rolling down the lane, it really creates kind of maintains its motion. If we really think about it as one end of the ellipses is going downward, another end of the ellipses, of course, will be rotating upward. Well, if you stack these three ellipses on top of each other, as we did in this design, you can imagine that no matter how that ball is rotating, there's always one portion of the ellipses that's going to be rotating in the downward motion, whereas there will be another ellipses balancing it out that will be moving in an upward motion. So what this really does is it maintains the differential while it's in motion. And from the testing we did internally, we could definitely see that this created a tremendous amount of mid-lane read and motion, and when it started, it just kept going. The continuation through the pins was really amazing. Now, as far as the drilling of the ball, this ellipses theory also had kind of an interesting thing similar to the Cell. It's very driller friendly. By those ellipses, the way they're balanced, it actually creates contoured RG planes. If we go back to the studies that USBC has conducted on axis migration, RG migration, we know that those planes or shapes basically control ball motion. So by creating a weight block shape that has very clean, very smooth RG planes, it means that when you put the holes in the ball, no matter how you drill it, you're still going to maintain that very clean, smooth motion. So it is very driller friendly. And here you can also see on this particular page just the differential and the intermediate differential, the PSA strength of the ball. So you can see 12 through 16, as I mentioned earlier, it is indeed the exact same weight block shape in all of those weights. Now, as far as the Coverstock, we of course wanted something that was very continuous, which of course would have been the weight block. That shape just gave us really good constant motion, but we also felt that it was necessary to try and give the ball a little bit more mid-lane read. And one of the ways that we can achieve that, of course, is through the strength of the Coverstock. So if we look back at our earlier series, say the cytoplasmic series, for example, which made the Cell so popular, we wanted to take the same concepts, the high RA values that really give it traction in oil, but we wanted to try and move it into the next generation of technology. So this Insight Coverstock, we really wanted to maintain those same RA values, but you can notice a key difference here. If we look at the picture in the bottom left, you'll see that there's a lot of red, but there's also a lot of really deep valleys. These valleys, of course, a little bit of displacement for oil, but what we found is over time, of course, those peaks, they kind of wear off and they break down, and once you get a little bit of wearing on it, you lose a little bit of ball motion. So what we were looking at with the Insight Coverstock is how can we maintain that strong read, maintain those strong RA values, but give it, maybe a little bit more, but also a little bit more durability. So if we take a look at this picture on the right, you'll see that there's just as much red, which represents the high RA values, but the fact is there's a lot of substructure in between each one of those peaks. So that substructure helps create more traction even as it wears. As you can imagine, if some of the big peaks start to wear down, you can see that there are fresh peaks below them. So this does a couple different things. It makes the Coverstock extremely strong, just as you'd expect from a crown ball. But on the flip side, it also means as it wears, there's going to be more and more substructure that's going to help maintain a little bit longer durability, a little bit more longevity, but also give it that really early, strong mid-lane read we're looking for on those heavier oil conditions. Now, one question you might be asking is, where does the theory fit in with our current product line? So we compared it to two of our other crown balls. That would be the Mutant Cell and the Mutant Cell Pearl. As you can see in this graph, we had one of our ball testers, Mr. Steve Klemkin, was bowling on a heavier volume, longer pattern here. I believe it was 41 foot. And as you can see, we compared the three of them. The theory was the black line, which you'll see was the strongest, picked up a little bit earlier. Then you have the red line, which was the Mutant Cell, and then the Mutant Cell Pearl. Now, if we really look and compare these numbers, I can tell you a couple different things that really stand out. If you look at the Mutant Cell, the red line, you'll see that the break point, and this would be the point where the ball changes direction. So even though it did start reading the lane a little bit earlier, and it did start into its hook phase, you'll see that the actual change in direction wasn't achieved until 44.3 feet. Whereas if we look at the theory, thrown on the same trajectory, same line, it actually started to change its direction at 43.26 feet. So it did indeed pick up about a full foot earlier, but you can see the weight block shape matched with that Insight Coverstock actually allowed it to start reading the lane, and it did start its hook phase a little bit earlier. So that 1 foot does give you a good idea where it actually changed direction, but you can see in this particular graph that the Insight Coverstock with that Triliptic weight block really did start its hook transition a lot earlier, so it did give you a lot more mid-lane and a lot more continuous motion. Now, one thing this graph doesn't show us is how amazing the reaction was through the pins. Those ellipses, as they're rolling, just created an amazing amount of motion and continuation even after impacting the head pin. And then I will hit a little bit here on the Mutant Cell Pearl. It's exactly what you'd expect from a pearl. Went about 1.5 feet further down the lane, and it did go a little bit further, but it did have a little bit more angle on the back end. But when we were on this heavier volume pattern, as you can see, it did go a lot further down the lane and didn't cover quite as many boards as, say, the Mutant Cell or especially the Theory did. So this should give you a great comparison to two of our other very strong crown line balls, and it really will show you that key difference when we're releasing a ball. Why did we feel this was important? And you can see it right here in the graph. It reads the lane a lot earlier, has a lot more mid-lane to it, just a very continuous rolling arcing motion that we feel is going to be extremely successful, especially when you get on those heavier or longer patterns. Moving on to the Nomad Dagger. The Nomad series has been extremely popular. In fact, I do believe that that particular weight block shape, the Rotary, is one of Wes Malott's favorite balls, and even on tour we know that a lot of our players have loved to throw this ball on a wide range of conditions. Our amateur, PBA staff, everybody has had a tremendous amount of success with this Rotary weight block. So when we introduced the Nomad and then the Nomad Pearl about 1.5 years ago, it was one of the most successful mid-line, mid-price balls that we've ever introduced, just because it has such a clean motion to it and such amazing carry at the pocket. So it was a natural step, if you will, to introduce a UltraVision hybrid version of the Nomad. So whereas you had the UltraVision Solid on the original Nomad and then the UltraVision Pearl on the Nomad Pearl, the UltraVision hybrid is just going to give you exactly what you'd expect. A little bit more mid-lane than, say, you'd get out of the Pearl, but still a little bit more entry angle than you'd get out of the Solid. The design and intent on this, once again, it was just one of those things that we realized was necessary because the Nomad series had been so successful we wanted to give something that fit right in between. If the Nomad was just a little bit too much, let's say the Nomad Pearl had a little bit too much flip on the back, a little too hard to control, you didn't have something in between, well, this is that ball. So the design and intent really explains why this ball is going to be successful. And for a lot of bowlers, it's been extremely successful, be them strokers, crankers, tweeners, anywhere in between. An amazing reaction out of this ball on a very wide range of conditions. Now, getting into the weight block, of course, we've used this quite a few times, but I did want to hit up on something that's kind of unique and does set this rotary weight block apart from many of the others on the market. Is you'll notice if you take a look at this weight block shape, there is no core around it. There's no light filler, no wrap material. Whereas you'll see on a lot of balls, you've got the 1/2 inch, 5/8, whatever it is, that uniform thickness of the shell on the outside and then the lightweight wrap. You'll see that in this particular design, we actually integrated the heavy, dense urethane, the UltraVision hybrid reactive cover stock into the actual design of the weight block itself. So if you take a look at the shape, you've got the dense sphere in the very center there. That helps lower the RG just a little bit. And then you have the actual shape of it combined with the urethane. It gives us a very high differential ball. Now, one reason why we feel that it's so successful is by eliminating the core on this particular design and going straight from the weight block into urethane, what we're allowing, or what will happen, is you actually get a higher coefficient of restitution. What that means is when a ball impacts the pins, of course there's energy that is transferred from the ball directly into the pins. Well, by going directly into the urethane, we're actually able to increase that value, which means when it hits the head pin, more energy is actually transferred from the ball into the pins, and what we feel that equates to is better carry. So this is something that we feel really helps set this apart and is one of the reasons why, as a mid-priced ball, it has been so incredibly successful, as it does have a tremendous ability to carry on a wide range of hits from extremely light to extremely heavy, just because of that higher coefficient of restitution. Now, there is one interesting thing that also comes from not having that core material, is the fact that it gives you a lot more versatility when you go to drill it for your customer. Here you can see in this particular example, the Nomad. This graph up here is all of the information taken from it before it was drilled. So this was this ball in this corner before we put holes in it. So you can see that it has the differential that we'd expect. It is an asymmetrical ball, so it does not have a PSA strength to speak of. And then you can see the lower RG value of the ball. Now, after we drilled it, when we evaluated it, you'll see that this layout that we chose, the 4x4x1, actually increased the differential of the ball quite a bit. Here you can see it gained 0.009. Essentially, differential is what? It's the wobble of the ball. It's the imbalance of the ball. It's the flare potential. So by increasing that differential, the ball is going to flare a little bit more, which for your average bowler equates to more motion, more back end, a stronger ball reaction. And then we even went even further with this particular ball, and we put a balance hole in it. So you can see this balance hole here. We measured from the center of grip 4.5 inches over, 2.5 inches down. And then we used a 1-inch drill bit, and we drilled 3 inches deep. What you can see here is that actually increased the differential up to 0.068. So this is something that's very interesting, and you'll notice if you've been looking at this graph that it went from passed all across the board to failed. Well, the reason it failed is during manufacturing, USBC has certain limitations on these values. How much differential can you have? Their current rules state that the differential of a ball at the time of manufacture cannot exceed 0.060. So you can see up here when it was undrilled at the time of manufacture, it was well within that tolerance. But by drilling it, you were able to actually get a higher differential, which makes this ball motion even stronger. So even though we couldn't release the ball with an 0.63 strength, as a pro shop, there's no limitation on how you drill it or how high you can boost this differential. So keep in mind when you go to drill this for your customer, you're actually able to greatly increase or change the reaction, fine-tune it, just based on that balance hole location, because you're removing so much more of a heavy, dense material, that urethane cover stock, the UltraVision hybrid. So this gives you a great idea. With the first ball, the theory, we realized we wanted to make it extremely smooth and clean. Those RG planes make it very driller friendly, gives you that continuous motion no matter how you drill it. And then of course with this rotary weight block, it gives you something where if you put the balance hole in it in the location you need it, you can definitely increase that motion. Or on the flip side, you can also greatly tame it down if you want to get it a little bit smoother or a little bit weaker, say for your very high rev or slower ball speed players. As far as the FAQ on the Nomad Dagger goes, the Nomad Dagger really does fit perfectly in between the Nomad and Nomad Pearl. As I said earlier, it has the hybrid version of it, so you get a little bit more mid-lane, you still get a good entry angle, so it fits very well in between the Nomad and the Nomad Pearl. If you were to build, say, an ideal 3-ball arsenal, say taking it to league, the 3 balls that we would recommend would be the Theory, of course, because we do believe that is our heaviest oil ball to date. And then the Nomad Dagger fits perfectly in the middle on a very wide range of conditions from medium light to medium heavy. And then when the pattern starts to break down or you're on a lighter volume pattern, something like a Riot or a Dark Star would do great. Now there is one thing I do want to mention. The Nomad and the Nomad Pearl were both released at a 1500 grit polish, as is the Nomad Dagger. So the reason behind that is we do feel that with that particular weight block shape and the different strengths of our cover stock, be it a pearl, a hybrid, or a solid, you will get a different motion out of it even if you have the same finish on it. But by no means does this tell you that you can only use the ball when it's polished. So if you want to get a little bit more motion on it a little bit earlier, you can definitely knock the polish off of it with a 500 or 1000 grit and really add more motion to it overall, make it just a little bit stronger. So I want to thank you for your support and thank you for your time listening to this. If you do have any questions, please feel free to give us a call at our tech number listed down here at the bottom, or of course you can email us directly at tech@rotogrip.com. Thank you very much.